So previously we were graphing inequalities. Is that an inequality? What is that? So this one's an equality. We usually call them equations, not equalities, but that's an equality. 2x plus 7 equals 10. That's an equation. That's an equality, right? So this, what's that? Inequality. That's an inequality. Less than, greater than, what else? Yeah, less than or equal to, greater than or equal to. Also this one, which we don't use that often, not equal to. Okay? But mostly greater than, less than, greater than or equal to, less than or equal to. And normally when we look at this, we say x is greater than 4. But can we read it the other direction? Start with the 4. 4 is what? Less than. Okay. And you can read it either direction, which is helpful when it says something like this. See, because we always want to think of what y is. So we always want to start with the variable when we read it. I wouldn't read this and say negative 2 is greater than y. I would look at this one, Tayden, you paying attention? And I would start with the y and say y is what? Right, because that's what I'm going to have to graph. Remember graphing these? So here's 0. Here's negative 2. Open circle or closed circle? Open circle, okay. So we're not including negative 2. We can't put a negative 2 here, can we? You with me, George? You having a hard time today? Okay. But what is y? Y is what? Less than. Yeah. And where are the numbers less than negative 2? I don't know right and left. Up the number line, down the number line. Okay, down. Less than, that's down the number line. Yeah, if you tell me to the right or to the left, that doesn't make sense necessarily in my brain like greater than, less than. Up the number line, that's greater than. Down the number line, that's less than. Is that okay with you guys? You all right with that? So that's what we have been doing. We've been doing that for a couple of weeks. I think you guys are all fine with that. So now, let's make things a little more interesting and do something like this. So we're supposed to solve this and graph it. Now what do you think? I don't think we've solved an inequality. We've solved equations, but we haven't solved an inequality before. Can we do it the same way or not?
That's how I've been taught.
That's how you've been taught? So what do we do to both sides?
Add 6 to
Or do we have to add 6 to both sides? What would happen if we didn't add 6 to both sides?
That would make it so confusing.
It wouldn't be less than or equal to anymore, would it? Okay. So these will cancel out, and x is less than or equal to 16. Let's see if that makes sense. If I had, I don't know, 4 subtract 6, is that less than or equal to 10? You guys agree with that statement?
Yes.
Who says that's true? Okay, think some more. Some of you didn't vote. Who says it's true? Everyone in agreement? Dallin? Is 4 subtract 6 less than or equal to 10? Okay. Got to be a voter. You got your American flag thing on. Okay. So if I add 6 to both sides, is it still true?
Yes.
Yeah. Okay. So it's just like solving an equation. There's no difference. You add the same amount to both sides, you subtract the same amount from both sides. There you go. And then can we graph this?
Yeah.
Now let's say I'm lazy. Does every mark on my paper have to be a 1? They don't have to be 1s, but if they're not 1s, I need to label the first 3 so that everybody knows what's going on. And then I can say, okay, here's 16. Okay, so there's 16. Open circle, closed circle. Can it be equal to 16?
Yes.
Count it, right? Dot it in. Okay. Up the number line, down the number line.
Down.
Down the number line. Okay. So I solved the inequality and I graphed it. What do you think?
Yeah.
Augustine? You happy with that?
Yeah.
Okay, that's not a big deal. Some that can be a little weird for you. Okay, this one has decimals in it. Does that change anything?
No.
No. What are we going to do to both sides?
Minus the 1.4 by both sides.
Okay, now tell me about this thing. You want to read that to me? What does it say?
Negative.
Don't start with negative. What's the important thing? What are we thinking about? What are we comparing? The m. Start with the m. What is m?
M is greater than 9.
There you go. M is greater than negative 9.4. Now, how the heck do you graph that? Okay, so how do you show 9.4 on the graph? So here's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where's 9.4? Pretty much the middle, right about there. And if I label it and say that's 9.4, then that's 9.4. Okay? Open circle, close circle. Open, yeah. Open circle. Up the number line, down the number line.
Down. Up.
Up, greater than, yeah. So up the number line. That's it. One more little step than you've been doing before, right? So you just have to solve the inequality, put it on a graph. On some of them, you don't even have to do that on today's assignment. Some of them just say, let me see if I can find it. Which number would you add or subtract from each side of the inequality to solve it? 4. We'd subtract 4 from both sides. That's all you have to say. You don't even have to actually do it. Okay? One of the questions today is compare solving equations using addition with solving inequalities. Solve an inequality, solve an equation, compare. What do you guys say about solving these two problems?
They're pretty similar.
They're pretty similar. I'd even go further than that.
You're similar.
We do the exact same thing, right? We don't even, you don't even have to learn anything new, do you? Allison, you happy about that? Cooper, you happy about that? Okay. So we're going to solve them the same way. Here. Why is this inequality equivalent to that inequality? Do these two mean, do they represent the same thing? What do you think, Peyton? Oakley, what do you think?
Yeah.
Yeah? So if I subtract 5 on this side and subtract 5 on this side, does it still represent the same thing?
Yes.
It really does, doesn't it?
Wait, why
Okay.
would that be the same thing? Because if you put them two together, it would make negative 6. Well, negative 4.
Well, I'm starting here. See, you guys are, I think you're used to this, like, okay, let's add 5 to both sides, and it's still equivalent, right? Well, what if I just start with something like that and I subtract 5 from both sides? Is it still the same thing? Let's look at an equation. Okay? Do those mean the same thing?
Yes.
Yeah, they mean the same thing, don't they? Look, it seems weird to go backwards that direction, you know, backwards, but they mean the same thing, don't they? You with me, George? Okay. All right. Okay, so turn over to page 64. There's a microwave sitting there. These problems make you think a little bit more. I want to go through this with you. A circuit overloads at 1800 watts. I'm going to write that number down. 1800 watts. That's the overload. Now this is how you solve a story problem, guys. You write down every problem it gives you, and you write down what you're looking for. Okay, if you do that, you're well on your way. So that's the overload point. You guys ever plug stuff in, and then finally you plugged one thing in and it kicked a breaker off? Yeah? Okay? Because it's just drawing too much power, and if you put too much power through a wire of a certain size, it'll get too hot and it can start a fire. And so there's breakers, and they kind of keep track of how much power is going through, and if it gets to be too high, they'll kick off. Okay? And they'll stop you from doing that so that you don't just light everything on fire. They're definitely a safety mechanism. Don't override them. That's a bad idea. All right, so you plug in a microwave. Microwave uses 1100 watts. Then it says, write and solve an inequality that represents how many watts you can add to the circuit without overloading. So I'm going to use W as my variable. That's what I'm looking for. How many watts can I put on here before the circuit kicks off? So can we write an equation that represents that? Or it's not an equation. Not an equation. What is it called? Inequality, right? Because, are you guys all thinking 700? Who's just thinking 700 right now? Okay. Do I have to plug something in that takes exactly 700? No. In fact, what would happen if I did plug something in that took 700 watts? It'd trip it off. What if I plug something in that took 699? What about 500? What about 50? So there's lots of possibilities, right? Okay. So we're using 1100 watts plus, how many more can we plug in? Do we know yet? We haven't, pretend like you already aren't thinking 700. What am I going to put right here? Do we know? That's our variable, right? And then we're going to compare that to 1800. Do we want this to be less than 1800, greater than 1800, less than or equal? What do we want it to be? What happens if it's equal to 1800? Okay, so what do we want it to be or equal to or not? Okay. So there it is. Now yours could look a little different than this. You could say the number of watts I have left plus the 1100 I've already used needs to be less than or equal to 1800. You could say, well, I've got 1800 and the amount I want to use, I want that to be less than it. So I'm going to put my watts, oops, here. How would my symbol be? See how the alligator still wants to eat the 1800? Does 1800 watts need to be greater than what I'm going to plug in plus what I'm already using?
Yeah.
Do you see how all these mean the same thing? So there's lots of different ways to write it, but they all mean the same thing, don't they? Can we solve it? You guys were already thinking 700, weren't you? So look at the possibilities. Can you plug in your radio?
Yes.
Toaster? No. Blender?
Yeah.
Hot plate?
No.
Clock radio and blender?
Yes.
Okay, there you go. That's how it works. Okay, so I'm wiring, I just got done wiring my house, and now I'm doing the basement, and we don't do watts, we use amps. So I have 20 amp breakers.
What's the difference between the two?
So watts and volts and amps are all related, okay? So 20 amps will relate maybe, let's say, to 1800 watts, kind of the same idea, all right? And there's a formula that kind of relates all of them, but we won't worry about it too much. Just think of amps as, again, how much amperage you're using is how much power you're drawing at a time, okay? So I try to keep, so I have a room here, let's say, and we're putting plugs in, right? And we got to have a light up in the top of the room, don't we? Right? How many plugs and lights and everything do we want to do? And so we try to keep that to around 9 outlets, we call them. An outlet, that can be a plug. You guys think of those as outlet. But like a light, we can think of that as an outlet. Okay, anything where power's going out. And I try to keep that to about 9. It doesn't seem to happen very often. It always seems like you try to keep it to 9 and then you always end up going 10. But that's okay, because we figure we're going to use about 1.5 amps per outlet. That's what you can kind of figure. And so if we use 10 of them, how many amps would that be? That'd be 15 amps. Is that still under what I can use? That's still under what I can use. And so that's the idea. Now, could I plug stuff in and go over that? Yeah, like if you plug in some of those heaters, you know, those space heaters you plug in, some of those use a lot of amps, a lot more than 1.5. So if you plugged in a bunch of those and then something else, it might kick the breaker off. I know we were in a shed working and we had a honey spinner. So we have all these honey things in there, and it's got a motor up on it that spins it. It's like a big 55-gallon drum, and it spins them, uses a lot of energy. And we had a bunch of space heaters going in there at the same time because we wanted it to be like 100 degrees in there to make the honey kind of flow easier and stuff. Guess what happened? We kicked the breaker. And we could only use like 3 of the heaters at a time. We couldn't use all 4 of them. But that breaker's there for safety, because if you're drawing over 20 amps through that certain size of wire, through a number 12 wire, then that wire's going to heat up. And it's going to get so hot, it's going to start a fire, which would be bad. Right? Yeah, bad. All right, there's a little electricity lesson for you. So, here's the assignment for today. Now, I'm never going to tell you page numbers in this book, okay? Same as before. I'm going to say Chapter 2, Part 2. Does that make sense? That's what we're on. Look at the bottom of the page on 60. Well, turn over to page 65. Look at 65. See at the bottom where it says Section 2.2? Okay? So you can always see that at the bottom of the page. And you are going to do numbers 1, and then from 2 to 32, you only do the evens. Okay? And then you're going to do 36 through 46, you're going to do all of those. You have to show me all the work. You need to space out each problem. Number 1, number 2, number 3, number 4. Have space between each problem so I can see all of your work and your graph and I can see what's going on. Okay? Use a pencil. Any questions? What's going to happen if you hand it in and I don't see any work? Nope. Right? I'm going to hand it right back. Okay? So let's get as much of this done in class as we can today. I don't know if we'll get it done, but if you work hard till the end of class, then we'll figure out something for tomorrow. Okay, let's go.